Hello, 1 Jan 27th. Alright, let's do this. K inverse pairs array. For an integer array nums, an inverse pair is a pair of integers where ij is like that and nums I is larger than nums j. Given two integers n and k, return the number of different arrays consisting of numbers from 1 to n such that there are exactly k inverse pairs. Oh, I remember this one. That's gonna be huge. Okay, so it's 1 to n. What is easy? Honestly, how you think? All right, 1 to n. So if I have this, only consists of numbers 1 to 3 has a 0 inverse. So anything we call inverse is going left to right, and the left is larger than right. So if I have 1, that's 1, that's 1. The answer is 2. So given an n, right, let's say n equal to 4, k is equal to 2, right? So we have basically 1, 2, 3, 4, but we need 2 inverse. So I can say how many? Maybe it's dp, right? We can try dp. So you say, okay, we start from dp index. So it says starting from this towards the end. Oh, but this thing is changing, right? This thing is changing. I want to know how many there are. I can say remaining number of inverse. So here we need 2 inverse, right? Okay. So first one, I have some value to put in the first one, and if the first one is 1, then there's no inverse because it's the current smallest. It cannot generate any inverse. And if it's 2, and then we move on, right? And if it's 2, then we cannot generate any inverse. But at this position, I have n different choices, right? In this position, I have n different choices. So if I pick 1, yeah, then we can say what value has not been chosen yet. What value has not been chosen yet? Maybe it's not an index. Maybe because each value can only appear once, right? It can only appear once. What if we use a state of which one has been chosen? Well, but n is big, it cannot use a state. Okay, so 1 we don't have any. If we have 2, if we first position as 2, then we can generate at most 1, right? If first is 2, well, we can generate, yeah, we can generate 1. We're not at most, right? But for sure we'll create 1. If the first position is 3, we can generate for sure 2, because this is the first position Alright, and now we have 3 positions left. You have to put 1 somewhere, and that will generate 1. This is you have to put 1 and 2 somewhere, it will generate, right? So in this case, if k is equal to 2, I can put 3 at front. If I put 3 at front, then it's guaranteed we have 2, and then the rest we can do, that's 3 factorial, because we can move them around however we want. That is not true. That is not true, because we want to generate something with 0, okay? They cannot have any more, because if we do 1, 2, 1, 4, right? Now we have an additional 1, so it doesn't work. So with 3 at front, we're guaranteed to have 2, which is yeah, we have that. So we basically we say we want a 0, right? For the rest of the number we want a 0. So this is 1, only 1. 4 at front, it's guaranteed we have 3, but we can only have 2, so this can now go. And 1 will have guaranteed is to be, now we can do 1 or 2, right? So if it's 2, which means the remaining we need to guarantee 1, right? We need to guarantee 1. And then 2 is gone, right? 2 is gone. So we need to guarantee 1. That means to guarantee 1, yeah, it's basically when you call dp starting from 1. So we start from dp 0, right, with k remaining. And now if we pick 1, that's dp 1, k remaining. If we pick 2, that's dp 1, k minus 1 remaining. If we pick 3 is dp 1, k minus 2, and in this case k is 4, so this is k is 2, so we start with 2, this is 2, and this is 1, right? This is 1, and this will be 0. And whenever we have, let's say k is equal to 0, then the answer is always 1, because you only have one way to produce 0 inverse pairs, right? 0 inverse pairs. And whenever it's 0, it's AND, right? Okay, so now what we want to do is define dp from index 1 towards the end, but we have 2, and dp from index 1 towards the end we have 1, okay? So now we say we have 3 positions, right? 3 positions, but some value is already taken, right? Some value is already taken. Do we also need to have, yeah, in this case, didn't you need to also take care of because I need to know one inverse pair, right? One inverse pair. Don't you have to go through everything that you have so far? If we have, because I picked 2, right? I pick 2, and then we know that we'll have 1 inverse pair, so we have 1 left, and with all the values smaller than 2, it doesn't really matter where they're positioned. It does matter. It does matter. Right, it does matter. So in this case, we have basically 1, 3, 4. I'm going to create 1. So we can put 1 in the front, right? Then it's 3, 4 to try to find 1. So that will be dp 2, right? We find 1 pair, or we can put 3 here. If we put 3 here, then 3 will generate 1 because we have 1 smaller, right? 1 smaller, so what we need is, this is 1, 4, so it will be dp2 with 0. That's only one way. Or we can put 4, but 4 has 2. So that's not going to work, right? So we don't consider this. Now we have 3, 4. We generate 1. If we put 3 at front, then we only have 4 left. So that's dp3, the last one, need to generate 1, right? Or we put 4 in the front, and then that's a 3, and we can do that. That's dp3 and a 0. This one's good, right? But this, this basically, it's dp4, right? No, it's dp3, and then we just have a single value. And if it's a single value, and this, yeah, this is not going to work, but this is going to work, right? So this is kind of the last position, right? This is the last position. The last position, I need to generate 0. It's good. No matter what value you put in there, it's good. The value in front, I have 2 things left, right? 2 things left, and then it doesn't matter which one, right? We have 2 things left. So maybe it'll be easier to consider position and number of this left. So let's just say in this case is it's m by k. Okay, m by k. Okay, so maybe we'll do a m by k. Maybe we'll do a m by k array. So it is not guaranteed that how about just do k by n, because n is, now let's do k by n. Okay, so in this case with k by n, 1, 2, 3, sorry, 0, 1, 2, 3, this is position or index, right? And then this is k. Oh, it would be 0, 1, and 2. Okay, so the easy one is from the last part. This is 1, right? We have 0 inverse, right? The last position, 0 inverse, and these are all zeros. Okay, now we do 2, right? We have 2 left, so basically say we have 2, and 0 is always 1. 0 is always 1 because we only have one way, which is sorted way, right, to do this. But with 1 reverse, it's also have one way because you have 2 values and they are always different. So the inverse sorted will have 1. You have 2, that's not possible because we only have 2 values, so we cannot have 2 pairs. So that's a 0. So this is kind of, you can just do it. Now we have, starting from 1, so we have 3 positions, right? We have 3 positions. This is where we need to really figure out. I have three positions, and we don't know what numbers there is, right? We don't know what numbers there is. It's just three positions, but we do know that they are all different, and there will be some order. And does it really matter which value is which, right? It doesn't really matter. It's just three values, right? Just three values. And in fact, if you gave me 1, 10, 100, right, and then tell me what is the total number if I just move them around, is this any different from you giving me 1, 2, 3? It's exactly the same. So the number itself doesn't matter. What matters is just, the order, right? They all always have an order. So I can always say I put the largest, right? I put the max here, right? If I put the max here and then I want to have one different, which is always not possible, because if for the max here I have two values, so we cannot put the max here. So the most we can put is we can start with the minimum, right? So we put the minimum here, right? And then this is just going to be dp, because this is 1, right? So dp2, right? And then depending if we do 1, right? So it would be become here. And 2, 1 we already figured out. dp2 is 1, so at least this has a 1, right? We have a 1, so this is equal to 1. We put minimum, right? So that's the minimum. And then second minimum, right? If it's a second minimum, that will be dp 2, 0, right? dp2, 0, because I have the second minimum, and then I'm guaranteed I have 1 already. So what I need to know is for the remaining, we have 0 because we're dealing with 1, and that's it. So basically we're saying it's dp, oh shoot, I swapped it, so it's not 2, 1 or 2, 0. This should be 1, 2, because the row is k. Remember, the row is k. Yeah, that's the thing. I might get confused. The row is k and a column is the index, right? Column is index. So we say index is going to be 2, 0, and then 2. And then we just go 0, 1, 2, right? 1, 2 is 1, right? That's 1. And then 0, 2 is here. Oh, you might want to consider doing it the other way, because you might be able to use some. Okay, let's consider some other way. Again, n equal to 4, k equal to 2. Okay, so we say rows will be indices. Okay, rows will be indices. So we have 1, 2, 3, and now we do this. So I have 0, 1, 2, 3, and 0, 1. I always forgot the last column. 2. Right? Again, this is k. This is index. Right? So when k equal to 0, no matter starting from which index, is always 1. Right? When k is equal to 0, because we only have one way. Now we're going to say we're going to go from bottom up. Right? We start from 3. And we try to do k is equal to 1. And the last row is also determined, because it started from the last one, we only have 1. So these two are also always 0. Okay, so now you start with dp21, right? dp21, we have two values, okay? So if I go, so we have two values. If I start with a minimum, right, then, because this is 1, then we need dp3, 1, which 3, 1, which is 0, right? If I go with the max, then we need the dp3 0, right? Which is dp3 0, which is 1. So this value will equal to these two added together, so that's a 1. Okay. And I didn't use this one. Maybe I should just go for this one now. This is dp 1 1, right? dp 1 1. So dp 1 1 basically, because it's index, right? It's index 1 2 3. So again, if I do the minimum here, I need dp starting from 2, and because I'm going to do 1, so the dp2 1, right? dp2 1 is equal to 1, and then if I have second minimum, then I have 1 already, so it's dp2 0, right? And dp2 0, that's equal to 1. And if we do the max, then we get negative, so that's not good. So this is 2, right? Huh. So like these two added together become this. These two added together become this. And it should be these two added together become this. Right? Because the same thing, the smallest, you would do dp2 1, dp1 1, right? If you get a second max, so dp1 0, you got third max, it's not going to work. So it's going to be like this. And now we handle this, right? So we have dp2 2, right? dp2, we want a 2. We can say that equivalent, if we go to smallest of dp3 2, then that's a 0, right? We can also do dp 3 if we go 3 1 and then dp3. So yeah, so well, that's it, because I only have 2 positions, so either the minimum or the maximum, right? Minimum or the maximum, and both are 0, so this is 0, so I have 2, right? 2 difference. And now we do dp1 2. Either we do dp2 the smallest, right? dp2 2, dp2 2 is a 0, or we do dp, because I had 1, I have 2 values, right? I have 2 values. It's position, right? That's the position. And then maybe position is a difficult thing to do. I should just say the count, right? The count will be more intuitive. The count will be more intuitive. How many numbers you have, right? How many numbers you have, right? But I just finished this thought, right? So we have again position, and then if I put the second smallest, then I have 1, so we do dp2 1. So now dp2 1, that's a 1, so we have 1, which is yes, right? In this case, I have 3 values, right? If I have 3 values, we can get 2. There's only 3 2 1. That's the only way we can get. No, that's 3 pairs. This is 3 pairs. Hold on. So number 0. Okay, 2 generate 2 pairs. That's understandable. So now we have, right? We have 3 values, and I say I need to get 2 pairs, right? I need to get 2 pairs. So I can say I put the minimum here, right? Which is, yeah, what we say we put the minimum here, and then it's 2 to generate 2 pairs. That's not possible. Or I put the second one here, which will guarantee me 1, so the remainder need to generate 1. So just 2 1, that gave me 1, right? Or I get the biggest one here, dp2 0. dp2 0. Right, dp2 0. That is gonna be another 1. So this is a 2. Because I add this, this, this. Then shouldn't this add this, this, this as well? Right? So we do this. Don't we do this as well? We have 2 values. Right? We have 2. Oh, this is a 0. Right? Hold on. Index. This was the last position. Right? We have last position. How many ways do we have to create 0? I should just be yeah, it doesn't matter. You don't have one way. So you have 2 values, okay? 2 values. If I do the minimum, then it's the last one. We need to create 2. That's not gonna work. If I do the maximum, oh, because this one only has 2 to go through, right? It only has 2 to go through. We go to maximum. Then the previous analysis is wrong. Oh no, because here. Oh, it ends because I don't have enough. I don't have enough k to go through. But now I do have enough k. This is just I don't have enough number to go through, right? Because I only have 2 numbers, right? We'll do this 3, 1. I want to add another one, but I can't. So this one, adding these 2, but this is adding these 3, right? And for this position, which is dp0, which basically is dp0 2, right? And that is a 0 position. That shall equal to, if I put a minimum, that will be dp1. And if I put a minimum, then it's the dp1 2. If I put a second minimum, that will be dp also 1, right? If I put a third minimum, that's dp1, as I have if I have the third minimum, that guaranteed 2, so it will be dp1 0. So yeah, this also is add these. So dp1, I add all of them. So 1 plus 2 plus 2, so that's 4. That would be 5. Right, 5. So I think this answer should be 5. So I say return 5, and we try a 4, a 2. Yep, I think this is right, but I need to go through this one more time and not using index. And the index is a bit clunky. Right? Index is a little bit clunky. And we do have to create a prefix sum for this. Yeah, let's do one more. Let's say n equal to 5 and k equal to 3. All right. So again, I'm going to create this. So we're going to do 1, 2, 3, 4, and this is going to be 1, 2, 3, and this is going to be the count. How many numbers I have? Is it 1, 2, 3, 4, 5, and this is going to be the k. 0, 1, 2, 3. All right, hold on. I need to feed my cat. All right, I'm ending right here. I'll do another